So this is a very exciting moment for me, post-pandemic. This is the first time I've stood in front of a big crowd like this, and it's excellent to do it in our offices, so thank you all for coming. So Jim gave an excellent welcome, but I did just want to really thank you all. It's amazing to see this kind of attendance. For those of you that don't know me, my name is Spencer Kimball, and I am the CEO and one of 3 co-founders at Cockroach Labs. And we've been building this database now for about 8.5 years, if you can believe that. Time does fly, though. It really seems like only yesterday that we're 3 people, and we're now at 478. So we're approaching 500. And that scale for the company is fundamentally tracking the scale of our customers and the usage of the database. So that's extremely exciting, and I like that there's some proportionality in those numbers. We also have over 30,000 clusters that we're currently actively managing. And this is across our cloud platform. So that means both our serverless, where there's quite a volume, and that is increasing all the time, but also our dedicated, so the cloud database that we have that's fully managed. And that, of course, it was a very white glove service, and everything was really done manually, and now it's fully automated and very self-service, and that the state-of-the-art is moving constantly with both of those products. So that's very exciting. We also have many clusters, in fact, a somewhat unknown number out there that are self-hosted by our customers. Many of our customers started as self-hosted, maybe expanding into the cloud, so there's some hybrid usage there. And there are still some customers that are really actually taking a different path than the public cloud and building their own private clouds, sometimes with incredible scale. So it's really interesting to see the wide diversity of different deployment models in companies that are actually employing Cockroach. So Jim already showed this list of logos. It's a great set of presenters. I wanted to thank all of these folks in particular. Some have come from all the way around the world. Dev Sisters is a great example of that, so thank you. And of course, some of these are the most well-known logos. And I think what Jim already said bears repeating, and that is that all of these companies, if there's a single thread that runs through them, it's that they're leaders in their respective verticals. They're pushing the boundaries in terms of how they use technology, and we're happy to be part of that journey with them. So I'd love it if everyone could just give a round of applause to the presenters from these companies. Great. So I'm going to talk a little bit about the current and then what we believe is the future state of databases. This is really how we decide what to build and with what priority. It's kind of our model for how reality looks and how folks are using databases and how we expect them to evolve their usage of databases. So everyone is aware of the traditional database market, and it was roughly split into the OLTP, the transaction processing, and then the OLAP, the analytics processing. That's a fairly simple formula for how this market works. It's changing rapidly, and the forces that are changing and evolving it are many, but these are 3 to call out. I mean, one is that there's just this modern era of data. Right? There's more data than ever before. There's this data intensivity. You can collect it all. But increasingly, there are tools in the market that allow you to use this data, to draw insights out of it, to provide a fundamentally richer user experience. And that, in turn, drives user expectations. Right? In your vertical, if there's a competitor that has provided a new service that actually uses data to great effect and pleases or even delights the end user, that's something that everyone has to also accommodate in their products in order to really compete in the market. We have customers, and this is kind of mind-blowing because I got my start in the sort of client-server era in the 90s, maybe even in the late 80s when there wasn't even client-server. They have, in the course of a single operation, applications that actually can touch the database more than 5,000 times. That was something that if you actually expected that to work 20, 30 years ago, you couldn't run very many concurrent operations or have very many concurrent users. But these services are handling tens or hundreds of millions of these requests a day. So it's incredible scale out there. And that, of course, is driving those end user expectations, which need to be fulfilled. And then this is really this third part here about the infrastructure expertise that's necessary to run in these increasingly complex data architectures that underlie these new applications and services. It's hard to even hire these kinds of people. So these are the SREs and the DBAs and also the software engineers. And there's been, just in 2021, I believe the amount of money that went into venture capital was twice the total in any year prior to that. So there's this incredible influx of money that is fueling this evolution. And that is fundamentally creating a massive supply and demand imbalance in the labor market. So as companies look to satisfy these end user expectations and really use data to the maximum impact, they also need to find ways to build with the scarcity in the labor market for folks that have expertise in running infrastructure. And that's really what is driving evolution here. And we see that in the next 5 years, this sort of traditional market is going to continue to evolve into a much more unified market, where we're calling it here a single cloud data market. But think about how all of these user expectations in the usage of data, the storage of the data, how it all works in practice. It's many different vendors, all of which are bringing different services and tools to market. All of those have to interoperate. And increasingly, they all have to be run as services. So fundamentally, what you're doing here is you're accommodating new capabilities through these tools and through data. And you have to balance that by also trying to reduce the complexity. If you don't reduce the complexity, it only gets harder to run it, and you actually have to move in the opposite direction. So we see that services are fundamentally have to be the default. Everything has to be delivered as a service. And as we'll get to in this presentation in some detail, we also believe that that's actually moving towards serverless, so higher levels of abstraction to help manage complexity. And crucially, when you think about everything as a service, it's not just one vendor. It's not just the big cloud vendors. It's a lot of different vendors working together to build any competent data architecture. And so you really have to think about the services that you use being cloud agnostic. And not just cloud agnostic, but public versus private cloud agnostic, as there's just an increasing heterogeneity out there in terms of how people need to build. And then these capabilities, we think it's all about distributed systems, and interestingly, also about SQL or SQL. I think folks kind of predicted the demise of SQL not too long ago, and that's been proven quite incorrect. The beauty of SQL is just how elegant it is. Right, so you can create a simple declaration of what you want to accomplish, and then you rely on the system that you're querying to make the best optimized plan for how to satisfy that declarative query. And as you move up the levels of abstraction and have more and more services that are connected together, that becomes very important. You want the lower levels, the things that are hidden from you, that are managing the complexity, to be able to iteratively find better solutions. And SQL is a very elegant way to do that. So we actually believe that SQL is not just going to be continue to be around in the next several years, but probably your grandchildren will use it. So we'll see if that's true. But it's almost like our grandparents were using it. Not quite. Depends on how old you are, I guess. Great. So where does this go? Well, we actually think that in addition to managing complexity and increasing capabilities, there's also an opportunity to change how consumption works. And the reality is that if you think about serverless, it is actually something that is adding capability and it's helping to manage complexity. So it's really an extension of these two, but it's sort of a specific thing that we really think is going to affect all services. When you think about what the point of that is, it's kind of like, what do we want to do with every customer, with every use case? We want to be able to build better, more capabilities, and to build faster and to build cheaper. So all of those three things are what we're trying to accomplish here. And consumption is really how you can fundamentally change the cost equation, especially in the cloud with services. And what's this all about? It's about builders getting more autonomy, being able to iterate more quickly. So this is a great step back to just understand what the opportunity looks like and why Cockroach Labs exists in the first place. So just in 2020, we had almost $65 billion of spend in the database management systems market. And just in a year, that's increased to almost $80 billion. So that almost $14.5 billion market growth, 90% of it is cloud. So you can see how these trends are shaping up. Massive growth in data, but also massive growth in cloud, because it's truly a superior way to build architectures. We've had this graph for quite some time, and it's amazing how prescient it actually has proven. And it's really why Google fundamentally built Spanner and built Megastore and built big table and so forth. They were moving up this curve. And this curve is about developer productivity over time. And how do you actually measure developer productivity? It's those two factors that I mentioned before. It's about the capabilities that you give to them. What can they build? How quickly can they build using higher and higher levels of abstraction? But also, how do you manage that against the complexity? If you're going to go to multi-region, as many of you in this room know, it's not trivial. There's additional complexity there that has to be understood and managed. And so how do you make that as tractable as possible? Well, you also have to work on the complexity part of the equation. So we're constantly moving up this curve, and that's really where serverless distributed SQL takes us next. So I like this metaphor. It's somewhat imperfect, but I don't think that it's incorrect. But as you can see here, I don't know if anyone remembers that black phone, but it's hard to dial to 0. And then we moved to that cool brick in the 90s, or the early 90s, late 80s, and then to the first sort of little handheld devices that were could fit in your pocket, and then eventually to the iPhone. And fundamentally, this is about managing some of the complexity, but in the process of managing complexity, you open up the playing field to accommodate increasing capability. So the fact that you can put one of these things in your pocket changes the game in terms of what you can expect it to do. And that's really where the iPhone has taken a huge leap forward. We'll see what's next, but I bet this will continue to evolve. Everyone has seen these photos. I don't know how many of you have frozen yourself in one of these server rooms trying to install these things. That was how it worked in the .com days. Interestingly, even though it's rare, except for some large companies and folks that are building their own private clouds, to actually interact directly with these kinds of servers, we all do it through orchestration and a lot of different tools. And that's sort of the idea behind serverless. Let's move to a higher level of abstraction. So just the ideas of nodes and how big they are, and even potentially where they're located and what cloud they're in and so forth, is something that we can move away from. So if we're going to try to define serverless and what we mean by it, what are the benefits, I think is the right way to think about it. And really it's about moving away from the orchestration of individual servers. And so there's very little manual, but it's actually a little bit beyond that. I would actually say it's moving away from even thinking about servers. Because if you don't have to think about individual servers, how many of them, how they're connected, how a load balancer goes in front of them, what the networking looks like, and so forth. And that leaves a lot more time to iterate on the actual line of business use case. And that's, I think, what most companies are looking to move towards. And then within the concept of serverless, because it's a higher level of abstraction, you can get better and better at doing things that used to be manually done by the application or at the application level or layer. So this is really about just truly automatic scalability. It's not about saying, okay, well, we need this many nodes in our capacity planning and we can grow up to that. And then, well, we're getting to 80%. We might need to add some more nodes. Let's throw them in. Well, Cockroach automatically balances that. But you don't have to make those decisions anymore. And by the way, I'm using Cockroach as an example, but this applies across the entire stack, from the lowest levels to the highest levels. And so you want that all to be completely automatic. And fundamentally, when we're talking about scale here, it's not just about how big you can get, it's also about how small you can get, even down to 0. But certainly, a very fractional use case shouldn't demand an entire server, much less 3 servers, in order to, for example, have a sort of geo-replication across availability zones. You also expect that you can continually improve the resilience. It's just it's inherent in CockroachDB, but you can always make it better. And by abstracting above the servers, you can continue to improve that in a fashion that's transparent to the applications and services. And this is my favorite one, the programmatic management. So you can think about doing things manually with SREs and teams, even having developers of smaller projects manage these things themselves. And that's a lot. It's a lot even for a reasonable team with good skills. If you want to actually manage 10,000 of these or 100,000 of these things, let's say what we're talking about is databases. Imagine that, 100,000 databases. You have to do that programmatically. Nobody wants to touch that with a 10-foot pole if there's any kind of manual intervention necessary there. And so you want to be able to start these things and scale them restart them, scale them to 0. And all of that, of course, should be coming from automated signals, and all of that needs to be managed through APIs programmatically. And then you fundamentally, with serverless, have this opportunity to pay for exactly what you use. So that can drive a lot of efficiencies and cost. And you can actually do that to an arbitrary level of granularity, right down to the single request or the single byte stored or the single query done. So that's excellent. And so fundamentally what we're looking about is building, running, maintaining all the day one plus maintenance activities without thinking about the underlying servers. And right now, if you look at today, it's mostly when people hear the word serverless, they're thinking about the execution layers. So, if you're running a big application server, that might be Fargate in AWS or Google Cloud Run. Microsoft, of course, has their own, and there's plenty of open source and homegrown solutions to this. There's also an even finer level of granularity. It's actually decomposing those application servers into sort of like nano services or functions. Right? And that's an interesting approach. I don't think it's a one-size-fits-all, but this whole ecosystem is exploding. When you actually think about really deriving the true benefits of serverless, though, it's not just at that execution layer. It's all the way through the stack. Cockroach is playing down at a low level of the stack, and so we really want to bring the promise of serverless to databases. But it's a lot more than that. And if you think about what you need just to run CockroachDB as a serverless database, well, there's plenty of concern in the infrastructure layers that surround CockroachDB. For example, there's regions, there's different clouds, there's the availability zones. You might need global load balancers and sort of regional load balancers. You need Kubernetes clusters and all those different availability zones. Ooh, it's a lot of stuff, right? You want all those things to be serverless as well. And many of them are moving in that direction. So today, I think it's important to think about kind of where we are, what we've built, what we're building in serverless, and what that implies. It is important to note that these base capabilities, the things that we've worked on for the better part now of 8 years, or 8.5 years, these are actually required to build the serverless capabilities, to truly build them. So we're building on a foundation, and I think there's plenty more beyond that we plan to build on that foundation. But what are some of those things? Well, we set out to build a distributed database, and we wanted to do that in a way that was familiar for developers. So we made it Postgres compatible, which I think has paid significant dividends. We've automated the scalability of it. It can find equilibrium as you add nodes and as you take away nodes. There's, of course, active-active resilience for business continuity, and we've tackled the multi-region. And again, multi-region, as an example, was not something like serverless that we set out to build in the beginning, because that wasn't really the state of the art yet. But as we started to build our distributed foundation, we realized that there were customers that were very, very interested in accommodating users all over the planet. And so we said, you know what, this distributed architecture that can do geo-replication, originally intended just to be close by in availability zones, we can think about this as splitting out the data and partitioning it across geographies, across continents even. So that's something that has accrued because of the foundation that we built. And of course, when you start thinking about these high latency links between your users, you actually start to say, well, we'd love to just do transactions within a region, but if you have to do them across, how do you build a transaction model that can accommodate that as efficiently as possible? How do you build global tables, for example? How do you ensure that data is domiciled only in a single region close to a customer, whether that's for data sovereignty or just a customer's preference around where their data is stored? All these interesting problems. And again, it's about the distributed core capabilities of CockroachDB. And then when you actually think about serverless, it's okay, it's essentially a consumption modality on top of that core database. And so one Cockroach physical cluster can accommodate potentially tens of thousands of virtual clusters. So this is really a page out of VMware's book, right? They saw all of these use cases, each of which was demanding a single physical sort of bare metal machine. And many of those would use 10%, 15% of that underlying machine. And so virtualization actually allows you to parse that physical machine into lots of virtual machines and to use them far more efficiently. It's a very similar situation here. But I think the really key thing when you think about databases, and this is an almost impossible capability until you see it built, but you want to spin clusters down to 0. Because when you think about lots of different use cases, and I'll cover some of them, there's plenty of things out there that we create that are fractional or that are ephemeral in their usage. There's a transient utilization. And you want those to be run as efficiently as possible. You don't want something that runs for 10 minutes and then goes away to continuously demand, like for example, a VM be live. That cost, if you have 10,000 of those or 100,000 of those, will become absurdly prohibitive. So you want to be able to embrace the contours of your use case. And if you've got lots of ephemeral usage across your business entities or customers, that's what serverless is actually extremely good for. But if you can spin down to 0, you have to spin up too. And you need that to be extremely fast. Just as an example, some of the serverless database products on the market right now, they can spin to 0, but they can take 30 seconds to restart. So that use case, it doesn't work very well. You don't want to have a user latency of 30 seconds, and they'll probably go away for that or think the system's not working. So instant start's an incredible capability here, and then multi-tenancy is sort of what underlies the whole system and makes it work. So what does this lead to? Well, we think of it, I think the best description is something Jim came up with. It's pretty brilliant, but it's like a SQL API in the cloud. Not a database is traditionally defined in terms of how big the node is. Oh, it's a Sun Microsystems thing that costs $500,000 and we want to spend 100 or 1.5 million in order to scale it up by a factor of 2. That was how things used to work. And we've moved away from that. We moved to commodity hardware and so forth. That hasn't made it much easier, fundamentally. But this idea actually really, I think, can change the game and is actually in the process of doing so. So when we think about our vision, it actually maps with our mission here, which is to enable every developer out there who's intentional and wants to build world-changing applications. I think that's a great evergreen vision, and we're just going to have to keep pushing this state of the art to make this possible. So it is fundamentally about meeting developers where they are and leading them into the future, making it easier for them to build the next generation of apps and services. But we also want to make sure that we're creating efficiencies today. And when you think about the developer, it's about really getting your time back. Right? And many developers across many companies I'm familiar with, including ones I've worked at, have actually been tasked increasingly with running their services, scaling their services, because SREs are difficult to hire. And so you can actually scale your software engineers and you give them the responsibility of running these. Which is great, actually, I think. I think engineers should probably hold the pagers at least some of the time for what they build. It aligns incentives. Right? You want everyone to really build bulletproof services, not to hand it off and have somebody else suffer with it. So that's great, but you want to give them their time back. Like, how do you minimize how much effort they have to put into these tasks that are operational and let them build? And really to focus on what matters, right? Which is the business use case. It's always the business use case. How do you delight your users? And yeah, part of that is make sure that the thing scales for them and has low latencies and so forth. So these operational characteristics, the data architecture, the design of it is crucially important. But you kind of want to envision that once and then you want it to work. When I think about the real vision for a developer, is what can they build on their laptop? And then can they hand it off or sort of launch it into the cloud, and it will globally scale. So build on your laptop, but have that scale the way that, for example, Google launches applications. Right? They have platforms. You build with the platform, and then when you launch it, you get all the benefits. And that's really what we're looking to build here. And I mentioned sort of reimagining what the future could be with these new capabilities. I think there's some very exciting use cases that are opened up with serverless and multi-tenancy. One that appeals to me quite a bit is imagine a big software as a service application like Workday or Atlassian, right? Jira as an example. You have potentially hundreds of thousands of end customers. And think about the ticketing system in Jira. You can create filters in order to select tickets and take a look at what's going on in your queues. Those can be arbitrarily complicated. They can create noisy neighbor problems, as you can imagine, if someone creates a really big query across many, many tickets. So you really would like to give every one of those tenants or end sort of customers, you want to give them their own isolated database. Now, doing that for 100,000 would be absurdly cost prohibitive, and no one would ever think to do it. So what do people do instead? Well, they pack a bunch of these customers into multiple Postgres servers, as one example. right? And that can become very difficult to manage over time. Those costs are cumulative and probably nonlinear. And of course, you get these incredible noisy neighbor problems because there's no isolation built into that kind of a system. And again, you have many, many, many of these Postgres shards, essentially. So you're back to that problem of shards again, right? But you would like to build those kinds of architectures. I mean, how many SaaS companies are out there? I mean, probably many folks in this room are building that kind of an architecture. It would be excellent if it was trivial to simply create what feels like a completely isolated database that is specific to each customer. So that's a pretty cool one. We also see that development teams are typically spinning up kind of toy clusters, even in pre-production and staging environments. You might have, let's say, 3 regions running in production, but it can be so absurdly expensive to spin up a 3-region cluster in order to do pre-production work or to do regression testing, as an example. And so people don't do it. So then when you actually launch into production, there's some pretty interesting surprises that happen. Right? Latencies that you didn't expect, transactions that time out and blow up the system in other ways. Right? So there's all kinds of things that can be done to work on that, but it's kind of hard to beat the fidelity of a pre-production environment that's exactly like production. And that's something that with virtualization and something like serverless is very easy to do. You have a dev test cluster. It could be quite big. Let's say it's a 10 node or maybe 20 node physical cluster, and that can support many virtual clusters, as many as developers need. And they can spin them up almost instantaneously, and they can, if they don't use it, those resources are reclaimed very quickly. And if they come back after vacation, their cluster's right there for them. You're potentially hosting thousands of developers in your organization to move more quickly, to build more quickly, and to build better. So that's another very exciting use case. And there's also fractional use cases. This is quite common. I mean, the companies I've worked at, some have had, say, 70 externally facing applications or services. Other ones have had about 7,000. I think there's customers in this room that their organizations are hosting tens of thousands of externally facing applications. Many of those can be fractional. And even big applications start very fractionally. They might require just 1/10 of a server, but you may want that to be multi-region. You might want to mirror like wherever you have customers, and just a little bit of usage is in Australia. That's great. It should just use a little bit of the resources, not a full server. So combining fractional use cases such that the peaks and the troughs can balance, and you're not kind of stuck at that base load where you have to have an ability to scale up to the peak load, and you still need a little buffer. So you're really operating at like about 20% of where your server capacity is. It'd be much better if you could operate at 50 or 60% because you're aggregating use cases and letting some of the peaks and the troughs balance. So these are just some really interesting new ones. There's probably one more I'd call out, which is particularly interesting to developers, and that's new developer platforms. So there's a couple that I'm very interested in, Vercel, Netlify. These are actually systems or platforms that allow developers to build and deploy Jamstack applications. So it's really about the edge. This is our multi-region story. These things are really coming to fruition in the market out there. These companies are allowing developers to build something and then to deploy it, exactly like what I was saying. Can you build on the laptop and then have that deployed globally and scaled globally? Right? For those kinds of platforms, it makes a lot of sense to create a system of record for every one of those deployments. As everyone knows, when a developer hits a button that connects to their GitHub and deploys some Jamstack app somewhere, it's pretty unlikely they're actually going to use and scale that. Like maybe 1 in 100 of those, because a lot of that's testing and iteration and so forth. But eventually you get to some golden thing that actually starts to get some usage. That can scale. All the rest of those, the developer platform, that next generation developer platform, doesn't have to pay for all of those use cases beyond the 10 minutes they were run. Right, so this is like really incredible efficiencies, and this applies really across the ecosystem. So we really envision this as a global service fundamentally. So it's an extension of our cloud platform. And it has all the same benefits that we've been building for, the geo-partitioning, the multi-region, and additional ones as well. But again, this is fundamentally consumption-based. And we actually have a free tier now in serverless, and we're going to extend that. But the big goal here is, okay, you go a little bit past that free tier, you're paying for exactly what you use. That's the consumption-based. And then when you take it a little step further, you realize there's a huge ecosystem out there, and it's not just enough to build the serverless database. We have to integrate with that ecosystem. We have to make it work well from top to bottom. So there's an entire architecture that can be embraced. And so we think of this as distributed data functions. Think about stored procedures reimagined for this new world where the database spans many regions, many availability zones. Can it run the application logic right next to the data? Well, the database certainly knows how to do that. So that's one interesting idea. But more fundamentally, it's about how do you integrate with all of the tools out there. I mentioned all those application execution layers that are serverless now, that the clouds are providing, and many third parties beyond that. Cockroach fundamentally has to integrate with those things, and increasingly integrate with those things in an automated fashion. So that dream of going directly from what was built on the laptop to a global deployment is as simple as a single click. And then we also extend this vision to the enterprise. And the right way to think about this is it's an aggregation of all those developer experiences. Right? You really want to allow organizations to build and to manage more using fewer resources that are increasingly scarce. And the database as a service fundamentally can capitalize on these economies of scale. And leaving businesses increasingly, and this is quite a departure from the way things have continued to work even to the present day, but focus on the lines of business and iterating on use cases. Faster time to value. These are great things. And we also want to push the big areas of concern, like business continuity, scale, global replication, geopartitioning, into the database, away from the applications. And I mentioned before, like the excellent example of VMware and their virtualization technology. We're really taking a page out of their book, and it's about efficiently utilizing resources that are already there. And so many of you are, this final point here I think bears mentioning. It's a good one because I know of the customers in the room, there's quite a few folks here that are building their own databases as a service internally for their developers. And serverless is an excellent extension of that effort. Right? For the same reason we're putting serverless on our public sort of shared cloud platform, this is something that many of our customers will want to build internally within their organizations. Great. So, thank you all. I hope that was an interesting preview, I guess, of what we're planning to build and a summary of the things that we've been tackling over the last 8.5 years. This next 2 days, I want to stress it's about engagement and also alignment across us as a vendor and you as our customers and prospects. And the best way to do that is, of course, communication. It's bi-directional. So everyone, I hope you're coming here to really engage and to learn from each other. There are experts everywhere. And it's not just the folks at Cockroach Labs, although if you want to find out how the database is built, those are probably the right experts. We want to find out how the database is used, and you're all the experts on that. And fundamentally, what's working, what's not working? Where do we invest more? Where do we fix and iterate? So please come up, talk to me, talk to Nate, talk to everyone in the team. We're fundamentally building based on the signals we get from you. And so I think this is an excellent forum, the best we've ever had. So thank you all for attending.